Hello everyone, my name is Nina and I will be sharing the discoveries of the new stars along the Southern Ring Nebula today, as well as the research that went into everything for it. A summary of the discoveries. To summarize the discoveries, NASA's James Webb Space Telescope discovered 2 or 3 new stars along the Southern Ring Nebula. These newly discovered stars form the elongated curve along the Southern Ring Nebula. That's not to say that they are newly formed stars, rather the stars went unseen all this time. Also, researchers were able to discover the mass of the central star before it formed the nebula. These discoveries happened with the utilization of NASA's James Webb Space Telescope and the European Space Agency's Gaia Observatory. The researchers involved. The discoveries were led by astrophysicist and Professor Orsola De Marco of Macquarie University in Sydney, Australia. De Marco's research is primarily focused on common envelope interaction, evolved closed binaries, and planetary nebula. The team consisted of nearly 70 researchers who analyzed 10 different exposures of the Southern Ring Nebula. The exposures were observed with the James Webb Space Telescope, which were combined with previous images taken from the European Space Agency's Gaia Observatory. NASA's James Webb Space Telescope. The James Webb Space Telescope, or JWST, is a large infrared telescope, or rather observatory, that uses infrared light to capture exposures of our universe. According to NASA, the James Webb Space Telescope is the largest telescope orbiting in space. It has 18 mirror segments and is approximately 6,200 kilograms in mass. The primary mirror is 6.5 meters long. The James Webb Space Telescope was launched from the European Space Agency's spaceport in the French Guiana on December 25, 2021. So as you can judge by the date, it is still a fairly new technology. The James Webb Space Telescope is utilized for observing many phases throughout the universe, some examples including the formation of solar systems, as well as their evolutions. The James Webb Space Telescope is a crucial, modern instrument to understanding where celestial bodies in our solar system and beyond have formed. The European Space Agency's Gaia Observatory. The European Space Agency, or ESA, constructed the Gaia Observatory to be used as a 3-dimensional map of galaxies. It was launched in 2013. It's composed of 2 optical telescopes, which work with 3 science instruments to discover the locations of stars and their velocities, as well as split their light into a spectrum for further analysis. Technically, it's another spacecraft, in simpler terms. As the Gaia Observatory orbits the Sun, it maps the Sun at a distance of 1.5 kilometers beyond the Earth's orbit, which allows for clearer observations. And to the right, as you can see, this is the Gaia Observatory taking off into space. The Southern Ring Nebula. The Southern Ring Nebula is a planetary nebula, which means it was formed by gas that was shedded from a sun-like star. It's located in the Vela constellation and has a magnitude of 9.87. It's also referred to as the 8th burst nebula because it appears as a figure 8 through telescope observations at times. According to NASA, the Southern Ring Nebula is half a light year in diameter and 2,000 light years away. The center of the nebula is white, indicating that it's a hot white dwarf. The discoveries of the new stars. So moving on to the actual discovery, with the previous data that was collected from the European Space Agency's Gaia Observatory, DeMarco's team calculated that the center of the star was 3 times the mass of the Sun. After the central star shedded layers of dust and gas, it measured to 60% of the Sun's mass. It's important to note that the initial mass allowed for reconstruction of the star's birth and how the nebula formed. And these are close-ups that I wanted to show. These are the close-ups of the exposures taken from the NASA's James Webb Space Telescope. And as you can see on the left, this filter allows us to see the hot gas that surrounds the 2 stars in the center. And if you look, you can see the almost, I'm going to say, turquoise-ish blue and the red right next to each other in the center. And then on the right, you can see that the other filter allows us to see the star's molecular makeup, which flows from the edges into space. So continuing on, with the James Webb Space Telescope's advanced technology, it combined near and mid-infrared light from 3 different filters, which is how the exposures in the previous slide were captured. The redness in the left exposure has a reddish hue because a dusty disk components that orbit are similar in size to the Kuiper belt. Researchers proposed that a few more stars accompanied prior to the formation of the Southern Ring Nebula, which I will get into in the next few slides. Smaller star interactions. DeMarco explained that with Webb, it's like we were handed a microscope to examine the universe. There is so much detail in its images. We approached our analysis much like forensic scientists to rebuild the scene. So before the central star had shed its layers, the team proposed that 1 or 2 smaller stars participated in the next phase. The 2 stars acted like jets, meaning that they ejected from the nebula in 2 opposite directions. It's possible these are what the edges of the nebula are and why there is dust surrounding the dying star from those 2 points. As for where the companion stars have gone, it's possible they are too dim to see because of the 2 central stars, or they have merged with the dying star. And so, before I wrap up the PowerPoint, this is a 6-panel creation of the Southern Ring Nebula. So, I'm going to explain how the 5 stars created the Southern Ring Nebula. In the first panel, we can see that stars 1, 2, and 5, 5 being the smallest star, is orbiting star 1, while star 2 is cast off to the side. And to the second panel, we can see that star 1 has expanded, and star 3 is starting to project the jets from 2 opposing directions, top and bottom. In the third panel, stars 3 and 4 are projecting jets, while star 1 continues to expand as it ages. In the fourth panel, we are zoomed out to see that the light and stellar winds forming a bubble-like cavity. Star 1 is now surrounded by the dusty disk that I had mentioned earlier. In the fifth panel, star 5 is reacting to the dust and gas that's been ejected, creating the system of rings surrounding the outer nebula. In the sixth panel, this is how the Southern Ring Nebula looks today. And there you have it. That's how the Southern Ring Nebula most likely formed. Thank you so much.